None. Shut up, Bella.
Nope, can't find you. I sound so.
Hello? Hello? Shut up, Bella. Ah.
Yeah, you're on.
Right now?
Yeah, I see you. Nope, can't find you. I sound so much like. Go to your own live video. Don't watch your live video. So can you see me right now? Can you see me? It's gonna be a little late, Mom.
You found me by looking up AP review?
No, Deserae good.
And just go to YouTube?
Yeah.
Hello? Hello? Shut up, Bella. Where's my marker and stuff?
Right here. With the silence. Well, why do I sound so much like Mary?
Can you still see me?
Yeah. So far.
Why is it doing that?
Because it's gonna be lagged, Mommy.
But no, it keeps repeating.
Huh? No, I just started. What is this? So loud. So loud.
I can't see
Yourself?
Oh my gosh, it's running so slow. Okay. I'm afraid to do anything for fear that it will crash. Can you see me on the phone? Can you see me on the phone?
Yeah, I can see you.
Can you see me on the phone?
Yeah, I can see you. Oh, it's because it's echoing.
I know.
Yeah, I'm watching now. Oh, it's because it's echoing.
I know.
Yeah, I'm watching now. Oh, it's because it's echoing.
I know.
Yeah, I'm watching now.
It's just gonna be a little laggy.
Oh, it's because it's echoing.
I know.
Yeah, I'm watching now.
It's just gonna be a little laggy.
Oh, it's because it's echoing.
I know.
A little glitch with the sound.
Yeah, I'm watching now.
It's just
Are
gonna
you
be a little
seeing
laggy.
Yeah.
Like,
Go to it. I have a feeling you're just watching the video over and over and over and not actually going in.
Yeah, I'm watching now.
it's just
Are
gonna
you
be a little
seeing
laggy. Like,
Go to it. I have a feeling you're just watching the video over and over and over and not actually going in.
Yeah, I'm watching now.
it's just
Are
gonna
you
be a little
seeing
laggy. Like,
Go to it. I have a feeling you're just watching the video over and over and over and not actually going in.
Yeah, I'm watching now.
it's just
Are
gonna
you
be a little
seeing
laggy. Like,
Go to it. I have a feeling you're just watching the video over and over and over and not actually going in.
Yeah, I'm watching now.
it's just
Are
gonna
you
be a little
seeing
laggy. Like,
You go to it. I have a feeling you're just watching the video over and over and over and not actually going in.
Yeah, I'm watching now.
it's just
Are
gonna
you
be a little
seeing
laggy. Like,
You go to it. I have a feeling you're just watching the video over and over and over and not actually going in.
Yeah, I'm watching now.
it's just
Are
gonna
you
be a little
seeing
laggy. Like,
You go to it. I have a feeling you're just watching the video over and over and over and not actually going in.
Yeah, I'm watching now.
Are you seeing What is that in the background?
Okay. Can you hear me now? Can you hear me now? Okay. Can you hear me now? Can you hear me now? Okay. Can you hear me now? Can you hear me now? Okay. Can you hear me now? Is it on a loop for y'all? Because it's on a loop for me. Can you hear me now? Okay. Can you hear me now? Is it on a loop for y'all? Because it's on a loop for me. Can you hear me now? Okay. Can you hear me now? Is it on a loop for y'all? Because it's on a loop for me. Can you hear me now? Okay. Can you hear me now? Is it on a loop for y'all? Because it's on a loop for me. Can you hear me now? All right. Yeah, it's on that looping crap. Can you hear me? I'm hoping this is working at some point in time. This is so weird. Y'all get to be my guinea pigs. Did it? Fingers crossed. Alright, yay! Let's see if we can get a little bit of tutoring for y'all. Did I say 9 p.m.? I meant 10 p.m. Alright, yay! Let's see if we can get a little bit of tutoring for y'all. Just so you know, this is very weird because my screen is about 15 seconds behind. Just so you know, this is very weird.
You have to turn your sound down for it to work.
My screen is
That's why the echo's happening. It's the recording is picking up your sound. That's why it's echoing.
No, I turned the speakers off. I had speakers on and my microphone. Sorry, my daughter is talking to me.
Yeah.
I turned the speakers on and my microphone. Sorry, my daughter is talking to me. Grace, where's the Kleenex? Did I have? Sorry, trying to find my thing.
Here, I'll go
right.
get some tissue paper.
What questions do you have? I see y'all's comments pretty quickly.
Here you go.
What happened to that tissue? What happened to the tissue?
Look at the science rocks. It's pretty. It's pretty. Nice and pretty.
Alright, y'all are about to see some moving around everywhere. Alright, y'all are about to see some moving around everywhere. Basic vocab. Everything from generic genetics for Mendel, such as genotype, phenotype.
Basic vocab. Everything from generic genetics for Mendel.
Dominant,
such as,
recessive,
genotype, phenotype.
heterozygous, homozygous, dominant, homozygous, recessive. Then you need to know, obviously, sex-linked traits. You need to be able to tell me a couple of examples of sex-linked traits.
Dominant, homozygous, recessive.
Okay. Whether it's sex-linked recessive or that sex-linked dominant, which we can determine from the pedigrees.
Tell me a couple of examples of sex-linked traits.
Other terms you need to make sure you're comfortable with are the ones we discussed yesterday. Epistasis, pleiotropy,
from the pedigrees.
penetrance,
Terms you need
polygenic,
to make sure you're comfortable with are
multiple allele,
discussed yesterday.
codominance, incomplete dominance. And the list can kind of go on and on. I mentioned it again today. Differences between epistasis, penetrance, and pleiotropy.
Incomplete dominance.
Penetrance is an actual statistical term where we would actually find the calculations of a particular gene found in our population. So how many individuals have sickle cell anemia? How many individuals have Marfan syndrome, Huntington's chorea, that kind of thing. Pleiotropy is how many different things are affected by a gene. So, is cardiovascular, is tissue, is nervous, is connective tissue. So pleiotropy is many effects based on one gene. While epistasis is the covering up or masking of a trait, like the brown and black chocolate or brown and black labs covering up with a recessive E, causing them to be yellow. And then we had expressivity, which is how much of a degree is there in the traits because of a gene. Almost every single gene has a certain level of expressivity. Almost every single gene is pleiotropic. Okay. Polymorphic and conjugation. I'm not sure why conjugation is coming up. Did I have that somewhere on a review? That's just odd. Because conjugation was meiosis. Conjugation is sexual reproduction between bacteria and stuff, so that's kind of... Alright, well, Conjugation we already talked about. I mean, it's sexual reproduction. How bacteria can reproduce through binary fission, they can also reproduce through conjugation. So, alright, interesting. All polymorphic is break down the word. Polymorphic is you have many forms of a gene. So it's the gene itself can take on many different forms in a person's body, meaning anything from how hair texture can be in an individual, how a person's skin color can be. Polymorphic, it is just that word.
Hair texture can be in an individual. How a person's skin color can be. Polymorphic, it is just that word.
Your comment section is going a lot slower than ours did. I typed one thing and there are already 50 other comments questions.
Oh, you typed a comment, Grace? Sorry.
No, not on those. When I was watching my science teacher do hers, the comment section was going bam, 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 bam.
That was weird. Stream is continuing.
Sorry.
My stream went off, then it came back.
Yeah, it does that sometimes.
That was weird.
Alright.
Stream is continuing.
That is very odd.
My stream went off, then it came back.
It does.
That was weird.
Okay, I'm trying to see if there's any comments
Very odd.
that I'm missing by any means.
No, your context is so slow compared to
Okay, I'm
mine.
just seeing, I'm trying to see if there's any comments.
Heavens to Betsy, my daughter is
that I'm
talking
seeing
to
by
me.
name.
Ooh.
Heavens to Betsy, my daughter is talking to me.
Okay. Obviously, you're going to have to be comfortable with the pedigrees, dominant, recessive, sex-linked, all of that. So be sure you look at the small tips and tricks. And you are going to have a dihybrid or trihybrid, something like that. And you'll have to do a chi-square, just like on the paper worksheet you had.
Have a dihybrid or trihybrid, something like that, and you'll have to do a chi-square, just like on the paper worksheet you had.
Okay. Could you talk us through the last problem on the worksheet? All right. Yes, I will.
No, don't reach my phone.
Oh, heavens to Betsy
The
Grace.
last problem on the worksheet. All right.
Do y'all see what time it is? It is 10 o'clock at night, and this fool is still awake.
Betsy Grace.
I'm not tired. At all.
Do y'all see what time it is? It is 10 o'clock at night, and this fool is still awake.
Yeah.
Heavens. Okay.
Well, I was making cookies.
The last problem. So the first thing that's kind of confusing. Go to bed, child.
I
Yeah.
said cookies to make.
The last problem. So the first thing that's kind of confusing. Go to bed, child. Yeah.
All right. Is the fact that it gives you two letters
Oh, thank you.
representing representing the what was it? Bitterness.
It gives you two
That SU,
letters
that's kind of throwing y'all off.
representing
This is
the
an old AP question, so just ignore the fact that it has two letters, SU, and just replace that with S.
An old
S is a dominant allele that represents bitterness. I'm writing on my board while I talk to y'all. And then capital E was non-explosive rhymed.
on my board while I talk to y'all.
So replace that SU with just an S. That'll kind of help with a little bit of the confusion as far as what letters. So capital S is bitterness, capital E is non-explosive. So that means lowercase s is not bitter,
What letters?
and lowercase e is explosive rhymed.
Is non-explosive. So that means lowercase s
In the
is
problem,
not bitter.
it gives you the 4 possible phenotypic combinations and how many offspring you see with that.
In the problem,
So the first one, I believe it says, I don't have it pulled up, and if I try and pull it up, it's going to stop my stream. It's acting really weird. So I believe the first one said bitter.
first one, I believe
Non-explosive.
I don't have it pulled up, and if I try and pull it
The
up,
second one said bitter, explosive.
weird. So
Then non-bitter, non-explosive, non-bitter, explosive.
second one said
I think, correct?
bitter, explosive.
So the numbers that it gave you there, guys, that is your expected, or sorry, your observed population.
So the numbers that it gave me there,
Okay? Those numbers
or sorry,
are going to make their way into your chi-square calculation. That 96, 92, 81, whatever the numbers were. They're going to make their way into the chi-square calculation as the observed values.
96,
And if you remember your chi-square equation is observed minus expected squared divided by expected.
your chi-square equation
And you add up all of the possible samples in your problem. In this case, we have 4 samples, so you're going to have 4 of those calculations added up together.
the possible.
Now, to find your expected values,
In this case, we have 4 samples.
that's where the Punnett squares come in.
Calculations added up together.
So, it tells you in the problem
Find your expected values.
what 2 individuals or 2 watermelons you're crossing.
So it
And so if I remember, it says that you were crossing a
what 2 individuals
Bitter.
or 2 watermelons you're crossing.
non-explosive hybrid.
It says that you were crossing
I'm pretty sure that's what it said.
a bitter
So If it's bitter, that has to be dominant. If it's non-explosive, it has to be dominant. And the fact that it used the word hybrid tells you that it's heterozygous for both traits. So you should have a capital S, lowercase s, capital E, lowercase e. And that's your first individual. And then I'm pretty sure the second one, it said was recessive for both traits. So lowercase s for both alleles, lowercase e for both alleles. Now, just like any dihybrid problem, you're going to have to do law of multiplication. So, and I would love to be able to show you all the board, but it's not really going to help you considering that it's backwards for you. So, as my, oh, is it backwards?
It's like flag.
Let me see. Is it backwards?
Oh, is it backwards? Is it backwards?
Has it been 2 hours?
I guess it isn't backwards. Interesting.
Has it been 2 hours?
You go figure it out, child. Okay. I guess I can try. Sweet, it is the right way. Sweet, okay, then I'll go ahead and do the Punnett square. So if I remember the problem correctly, you should have that as your first individual crossed with a homozygous recessive for the second individual. That's what I'm pretty sure it was. Okay? So you'll have to do your monohybrid crosses for the S's and then your monohybrid crosses for the E's.
I'm pretty sure it was.
So,
So you'll have to do your monohybrid crosses for the S's.
I'm going to do the Punnett squares real quick. And I'm going to go ahead and do one for the E as well.
I'm going to do the Punnett squares real quick.
So just give me a second.
And I'm going to go ahead and do one for the E as well.
Okay, I'm hoping that that shows up well enough. Alright, so whenever you do your monohybrid crosses, the reason you're having to do this is the Punnett squares is what's providing you with your expected values, because they are your expected probabilities, right? Now, to do a dihybrid, you've got to remember that you have to take the fractions of phenotypes. We don't care about genotypes. So to do phenotypes, you're concerned with how many in these offspring boxes will show you dominance and how many will show you recessiveness. So you're looking for the capital letters or just recessives. So 1/2 here, or sorry, I should say 2/4. Don't reduce. Go ahead and say 2/4. And then 2/4 as well. And then same thing over here, 2/4, 2/4. Like I said, I'm pretty sure, somebody correct me if these aren't the values. I said I can't pull it up or it's going to stop the stream. So you'd have 2/4, 2/4 for each of them. Yeah. Alright. So why don't we reduce the fractions? It's not, you can reduce the fractions. It's fine. It's just not reducing the fractions just, I don't know, helps you to see the 16 probability. So you can reduce it if you want to. It doesn't matter. It's not wrong by any means. Okay? Now, just because you have these fractions doesn't tell you your answer yet. Because in the problem, it had 4 different phenotypic combinations. The same 4 you will always do for a dihybrid. How many individuals will be dominant for bitterness, dominant for the explosive rind? How many are going to be dominant for the bitterness but recessive for the rind? How many are going to be recessive for bitterness but dominant for the rind? And how many are going to be recessive for both? Okay? These are the 4 that the problem already tells you about.
And how many are going to be recessive?
So now you use your law of multiplication
These are the 4
to take the 2/4 times the 2/4. 2/4, 2/4, 2/4, 2/4.
Now, you use your law of multiplication.
That will then give
to
you
take the 2/4
your actual probability
2/4, 2/4.
for the same 4 that we already labeled as our observed. That it says bitter, explosive rind, 92 individuals. Bitter, non-explosive rind, whatever. So let's go ahead and do that.
Bitter, explosive rind, 92 individuals.
So 2/4,
Non-explosive rind, whatever.
2/4, right?
So let's go ahead and do that.
So 4/16.
So 2/4, 2/4, right?
Once you get all of that, seeing if I have any comments or anything. So all of them are going to be 4/16. And yeah, at this point, it would be good to go ahead and reduce. If you already reduced at the beginning, Shaylin, go ahead. You're going to have the same numbers as I do. That
And
each of these combinations are going to give you a quarter probability.
have the same numbers as I do.
Now, what does that number do for us? Basically, guys, all it is right now is it's a percentage. It's saying that to get that one combination, it's going to be 25% of the time. The other one, 25%, 25%, 25%. So if you're looking at a population of 100 individuals, 25% of them should look one way, 25% another, another, and another. So in that population that it gave us at the beginning of the observed,
25% of them should look one.
you need to total those up and get a total in.
So in that
Heavens to Betsy, Patrick Despain, why are you even on here?
and get a total.
Lizzie,
Heavens to Betsy, Patrick.
I got 4/16
Why are you even on here?
because you're taking phenotypes, and all you're ever worried about with phenotypes is dominant and recessiveness. So
You're
take
taking phenotypes.
the dominant S and a dominant E from the Punnett squares we just did,
And recessiveness.
which they are 2/4, 2/4, 2/4, 2/4.
The dominant S
So,
and the dominant
A dominant S is 2/4 the time. A dominant E is also 2/4 the time.
2/4, 2/4.
Multiply those together. The law of multiplication is always the one you do first.
The dominant E is also 2/4.
So multiply that across, you get 4/16.
Multiply those together. The law of multiplication is always the one you do
So
first.
now that you have your 1/4 for all of them,
Multiply that across, you get 4/16.
you will take that percentage essentially
So
and multiply that by your total population to figure out what your expected values were supposed to be.
and multiply
And
that
now,
by your total
for your chi-square equation,
what your expected values
Right.
were supposed to be. And now, for your chi-square equation,
you have your observed values, which is what the problem already gave you. You will have your expected values because you're going to take
you
that
have
1/4
values, which is what the
values you already got from the Punnett squares,
expected values,
and you're going to multiply that by your N, which is your total population, because you're going to add up
Punnett squares.
all of those individuals to get how many are you really looking at, 300 something, whatever.
Which is your total population. because
Now,
you're
since
gonna
all
add
of them are 1/4,
all of those
they're all going to be the same. They are all 25%.
300.
So your expected value for all 4 times you do this is going to be the
They're all
same.
going to be the same. They're all 25%.
But the observed is going to be different according to what the problem said.
For all
You'll
4
do
times you
this part of the equation 4 times,
but the observed
and just
is gonna
add
be
them
different
together.
according to what the problem said.
and that'll give you your chi-square value that you plug into the box.
Part of the
That's your
equation
answer.
4 times,
Okay?
and just add them together.
You have to get ahead of the competition, Patrick. Yes, yes. Shaylin, yeah, you do the 1/4 times the N for each one. They're all going to be the same because they're all quarter times this total population. But then, yes, you've got to do the chi-square equation for each of the 4 possible combinations. So you're going to have the observed of the bitter explosive rind minus the expected Then you're going to have another one. The observed value of the bitter non-explosive rind minus the expected So you're going to do it all 4 times.
Then you're going to have another one. The observed value of the bitter non-explosive rind minus the expected
I can tell you that this exact question of the dihybrid and using it for chi-square will be on your test tomorrow. Okay? And you will have a probability of a trihybrid where you'll have to do the law of multiplication and then the law of addition. Okay? So remember, in the law of multiplication and law of addition, the law of multiplication you always do first, and that's what we just did with the Punnett squares, where all you're doing is multiplying to find the 4 phenotypes. Dominant for both, recessive for both, heterozygous for both ways. It's always the same, right, for that one. But if you're doing a trihybrid, then you just have to multiply all the other combinations. And then the law of addition comes in last. That's where you add all those fractions you got for the question I asked. So if the question I asked was, give me all the possible outcomes for 2 recessive traits. However many different combinations you can get for recessive traits, you've got to add those together. Because the law of multiplication is an and question, and the law of addition is an or question. So, in the law of multiplication, you're saying this allele and that allele will make this phenotype. But in the law of addition, you're saying this genotype or this genotype will make 2 recessive traits available. Okay? So when you multiply the quarter times the total population, is that your expected value? And then you subtract, no. Okay. So, okay. I seriously don't have the values in front of me, so I have no idea what the values are even supposed to be. So if somebody could hit me up with the values, that'd be great. It's, yeah, Lizzie. Yeah, Shay. Lizzie's saying it right, and that's just funny that she calls you Shay. Observed minus expected squared divided by expected. So the observed values are that 88, 92, 96, whatever. And then minus it by the expected value that you got because you multiplied the 1/4. 1/4 times what the total was. So if it was 88, 96, 87, 92, add those together and then multiply the 1/4. And that gets you your expected. And then, yes, correction on yours, Shaylin, how you said divided by the total population. No, you still divide it by the expected value you got. Okay?
Yes, correction on yours, Shaylin, how you said divided by the total population.
Lizzie, did you get total population is 299? I don't know. She's asking you. Okay? All right. I'm sorry, somebody's texting me.
I don't know. She's asking you.
Okay.
Okay.
All right. John, okay, what's the difference between law of segregation and independent assortment? So there's a couple ways you can look at this. Both of them have to deal with how traits in general get separated into their gametes. But law of segregation is dealing with the alleles separating from each other for a trait. So this really makes sense whenever somebody is heterozygous. If someone's heterozygous for a trait, then one gamete can get the dominant, one gamete will get the recessive. And of course it's actually 2 gametes get the dominant, 2 gametes get the recessive because of replication that happened, right? But
and of course it's actually 2 gametes get the dominant.
Sorry, I just lost my train of thought. So the law of segregation is for one trait. Law of independent assortment is really when you're looking at multiple traits and how those traits actually separate from each other to go into the gametes. Because the independent assortment is saying that all traits are independent from one another and will randomly assort into their individual gametes.
Because the independent assortment is saying that all traits are independent from one another.
These are what, Grace?
Randomly assort into their individual.
So they're gonna be different.
Okay, sorry, I see some of y'all trying. Okay. Lizzie, I got your remind, so I'm going to see if I can open it. We'll see if it will open for me.
I see some of y'all trying.
Grace, did you already take care of the
Lizzie, I
cookies?
got your-
Are they out and on the pan, or what are you doing?
They're in the oven right now.
Okay, have you made the glaze?
Yeah, I'll do that.
Okay. Lizzie, I can see it. Yeah. So, Shaylin, so take the 88, 68, 62, and 81 and add those together. That gets your total population.
Yeah. So,
And then,
Shaylin, so take the 88, 68, 62.
okay, let me see real quick.
and add
Let me
those
make
together.
sure
That gets your total population.
that it was
And then
bitter, non-explosive hybrid, and then, yeah. So I had the other ones right. So yeah, so it'd be a quarter. So take that quarter times whatever total population you got,
hybrid and
and y'all are saying it's 299.
I have the other ones.
I don't know, I'm not
Yeah, so it'd
quick
be a
at math
quarter.
like that.
So take that quarter times whatever total
And so yeah, so you
population
take that
got.
88
Y'all are saying it's 299.
minus a quarter's worth. Square it and then divide it by that same expected.
And so yeah, so
Um,
you take that 88.
And then add all of those numbers together.
Square it
Yes,
and
they're going to be
divide by the
decimals.
same.
Chi-squares are always decimals, but you're going to add all those numbers together.
Add all
Okay.
of those numbers together.
Shaylin, just let me know if you still have a
Yes,
question
they're
on it.
Decimals, chi-squares are always decimals.
All right. Chloe kind of described it a second ago, so somebody's getting on the video a little
Shaylin,
late.
let me know if you stop.
Pleiotropy, that is when a particular gene
Second ago, so somebody's getting on the video.
creates a variety of
That
physical
is
traits.
when a particular
Okay.
gene
So, I've mentioned before, so like Marfan syndrome
variety
is not,
of
it's not just circulatory or muscular system, it's also connective tissue and neurological tissue that that one gene can have an influence on.
it's not just
Almost all genes are pleiotropic.
neurological.
Okay, there's very few genes that we can classify as not pleiotropic, because what you're saying is that gene doesn't influence
Very few
any other traits in the body except for that one. That's pretty rare to be able to find something like that.
that gene.
Yeah, you best be sorry. Okay. Epistasis, that is the black lab and brown lab situation, where if you were to inherit another gene, it has the ability to mask or cover up the phenotype of another. So in the black lab situation, if they inherit the recessive for another gene, it has the ability to either create a protein, cause a protein not to be made, some kind of downregulation of proteins, not allowing the pigment to be made. Therefore, genetically, the black lab is still a black lab. Like, the black lab still has a dominant B for his coat color. But because he inherited two recessives for this other gene, it covers up any black pigment coming out in his coat. So he's genetically, genotypically dominant, but phenotypically you see yellow. All right, and polymorphic. So polymorphic is a gene causing many different expressions in the organism. Okay, so how are they all connected? They're all connected in the fact that they all have some kind of influence on an organism's phenotype. Pleiotropy simply describes how a gene has many forms, and then polymorphic just describes the fact that you have many different phenotypic traits in an organism, and then the epistasis is the phenotypic being covered up or changed, modified by a gene. I'm going to adjust my camera. Oh, I've got it. sit a little bit more comfortably. I am chilling in my bed. All right. Okay. All right. What else can I answer for you? Oh my heavens to Betsy. Gracie's baking cookies for her teachers. And so we're making eggnog cookies. And she just came in and asked, what's rum? Yeah. Because it calls for you know, kind of cook some rum and put it in the glaze because it makes it so much better, right? Rum is an adult drink. You're not going to add rum, baby. No, not tonight. Yeah. All right. Oh my. All right. Anyways, let's see. Other vocab terms. Do you know, like I said, do you know a couple of examples of just basic autosomal dominant traits and autosomal recessive, sex-linked traits? Be able to tell me a couple of them. They're going to her teachers, Patrick. All right. So be able to talk about, you know, like I mentioned, achondrodysplasia dwarfism, right? That is it's actually a dominant trait. It's lethal if they're homozygous dominant for it. Huntington's chorea, also dominant. So in those situations, if the individual is homozygous dominant for those, like Huntington's chorea, you can be homozygous dominant for it, and it's not lethal. But what that also means is it's 100% guarantee that your children are going to get Huntington's, right? Be able to tell me color blindness, right? Sex-linked. Muscular dystrophy, sex-linked. Just go back through a couple of those examples. Then, don't forget you need to be able to do a genetic linkage map for me. Muscular dystrophy, right? Just go back through a couple of those examples. Okay. And a recombinant frequency question. You probably just said, what was that? Because you don't remember it because we literally talked about it real quick and moved on. Right? So the genetic linkage maps, those are the ones that I'll give you, like, you know, A to D is 8% of the time. C to B is 10% of the time. And D, B is 2% of the time. I just totally made this up. I have no idea if this will even work out like it needs to be. But a linkage map simply is trying to describe how close genes are on a chromosome, essentially meaning they're linked. Because the closer they are, the more likely they are to be inherited together. So they won't be separated by crossing over. So on these, you just make yourself a line. And remember, start out with the greatest divide possible. So we would start with CB. Just place them, C and B. Woohoo! Nothing special there. Okay. Notice I didn't give you which one? I didn't give you AB. I didn't give you AB because that one you'd end up just needing to figure out. So now the next one you can place is a D. So you can put DB is only 2 away from each other. So the question on this one is that D on the inside of the B or is that D on the outside of the B? Because it's only 2 away. Okay, so I'm going to go ahead and place this D on the outside over here and say that that's 2, this was 8. So does that make sense for the C, D, for it to be 10? Yes, it does. My math actually added up. Do you know how proud I am right now that I was able to just throw this down and it actually worked? What? All right. Now the only other thing to place is you would have to place the AD, and it's only supposed to be, you know what? I'm kind of kicking myself in the butt because I'm just now realizing It did not work out like I needed it to. Let me see real quick.
Kind of kicking myself in the butt. It did not work out like I needed it to.
So, hold on, let me back up for a second. This is the point in a live video that you really wish it was recorded, so you could just edit the crap out of that. Alright, so CB was 10.
The point in a live video that you really wish it was recorded, so you can
Okay.
edit the crap out of it.
D, B, yes, baby.
So CB was 10. Okay.
Baby, try, look in the freezer, see if there's sugar in there. If there isn't, there's a bag of organic sugar in the pantry. Okay, sorry.
Baby,
Alright, so you've got the CB, and then again, we can do the D on this side or the D on this side. And the thing that would help us determine that would be how far away is the AD from each other. Okay, so if we put the D on this side, 2 away, then AD would have to be 8 away from each other, so that could potentially be placed about here. So AD is 8 away, AD is 8, CB is 10, DB is 2, and yeah, so that could work out. Alright, Shaylin, so once you add up the values for the chi-square, is that your answer? Yes, Shaylin, it is. Okay. Organic sugar, yes. We don't buy it very often, and I can't believe she's now using all my organic sugar on those freaking cookies, and I'm probably not even going to get any of.
We don't buy it very often, but I can't believe she's now using all my organic sugar on those freaking cookies. I'm probably not even
Okay. The other thing that I was going to mention was recombinant frequencies. Those are the ones where you're trying to see, it's kind of like looking at a dihybrid. You're trying to see if there is any possibility to determine the recombinant offspring, recombinant meaning that is now a mixture of 2 sets of genes from the 2 parents, like it's the perfect blend of the 2, and you're trying to see what is that frequency. How often are you going to see these genes separated and recombined in the offspring? Super easy on this one. So if I was looking at the fruit flies, and I said fruit flies' gray wings are always attached to a gray body. So if I said gray wings and gray body, right? And those are the first set of parents. Like that's parent number 1. And I mixed it with parent number 2, that is black. Or sorry, gray wings doesn't really make sense. Vestigial wings. So that's the dumpy fly with a black body. Alright, so you mix your 2 parents, and you're trying to see how many different possible combinations and what our frequency is. So if I said that there were 15 of our flies that came out gray wing, gray body, well, that looks like parent number 1. So that isn't a recombination. And then if I said 15 of them were vestigial wing, black body, again, they're parent number 2, so that's not a recombinant offspring. But then if 20 was vestigial winged gray body and 20 was gray wing and black body, now they're recombinant. So all you gotta do, this one's easy, recombinant frequency, guys, all frequency ever is a percentage of a total. So I want the recombinant frequency, so I want that recombinant percentage out of the total. So you literally take how many were recombinant, so in this case 40, right, and divide it by your total, 70. Ding, ding, ding. You've got your frequency percentage. Nothing to it. You'd write that number down. You write 40 divided by 70, and you're done. That's it.
You've got your frequency percentage. Nothing to it. You write that number down. You write 40 divided by 7.
Shaylin, what are the components of genetic exchange in prokaryotes? John asked this question a few minutes ago about conjugation. It's conjugation, but you know, I don't know what's going on. I've got to look back at that review. Conjugation was meiosis and stuff. So I don't know why I have it on there. But yeah, it's conjugation. All that question is genetic exchange in a prokaryote. Bacteria can go through asexual, which is binary fission. That's not exchange. But they can exchange genetic information through what's called conjugation, where they literally extend their sex pili to each other and exchange their plasmids. That's why we have, staph infections that are antibiotic resistant.
In their sex pili to each other
So,
and exchange their plasmids. That's why
all right. Other things, I can smell those cookies. They smell really good, and I hope she doesn't burn them. So.
Other things, I can smell those cookies. They smell
All right.
really good.
See if there are any other questions coming in. I'm trying to think of some questions off the top of my head. Like I said, pedigrees. I love pedigrees.
All right.
I love pedigrees. I love for you to be able to figure out what they are and what the genotypes are. Or maybe I want you to guess at what the next offspring could have or could be.
Figure out what they are and what the genotypes are.
Is true breeding like if you have a dog that is a pedigree? Yes. The word true breeding you can just replace with purebred. They're the same thing.
Is true breeding like if you have a dog that is a pedigree? Yes.
Is the test really hard?
True breeding,
All right.
you can just replace with.
So I would say no, but I am adding a few problems in there. But right now I'm only at like 25 questions. Ugh. So that might be kind of easy in your eyes, but I want to get a little bit more than 25 questions. So we'll see.
That might be kind of easy in your eyes, but
I'm thinking I'm like sleepy or something because I think one of my eyes is closing and opening really slow, according to the video.
I'm thinking I'm like sleepy or something.
How many math questions will there be?
According to the video.
Like the chi-square.
How many math questions will there be?
Chi-square you'll probably get 2 because I'd probably give you a bigger one and a smaller one. Like, monohybrid kind of thing versus a dihybrid kind of thing. Law of multiplication, law of addition, expect at least one of those.
And a smaller one.
And I mean, that's it. Those are the only math kind of questions I can ask you on this. Chi-square and law of multiplication and addition.
Expect at least one of
So, nothing past that.
And I mean, that's it. Those are the only math kind of questions I can ask you.
So, sorry, I'm adjusting so the camera's moving.
Nothing past that.
Okay, anything else you can think of? Is there anything on the review that I haven't kind of addressed or anything?
Okay, anything else you can think of?
What would be an example of a strictly
that I haven't kind of addressed?
what would be an example of strictly law of addition? Okay, law of addition is the second component. That's when I'm asking for independent events occurring in your offspring probabilities.
I'm asking for
So, could the offspring inherit
occurring
this set of genes from the parents? Yes. Okay. Well, could they also inherit this set of genes from the parents? Well, yes, they could.
of genes
So,
from the parents.
because they could inherit this and they could inherit this, you basically now have set yourself as, well, the offspring could be this or this.
Because they could inherit this and they
So
could
when
inherit
you
this,
have to answer the question as a, my offspring could be this or that, that becomes a law of addition. Okay? When you're looking at separate independent events for creating your offspring.
that becomes a law of addition.
Does law of multiplication come first? Yes, it does.
Looking at separate
The law of multiplication is what has to happen for you to create, or you use your monohybrid crosses for, your AA and then your BB. Multiply those together to just see what your possible phenotypes could be. and then add the possible combinations together if I ask for possible combinations for offspring. And remember, those questions come as a what is the probable outcome for the offspring to inherit two dominant traits, or two recessive at least, something like that. That's when you bring in that law of addition as the second part. Okay.
Two recessive at least, something like that. That's when you bring in that law of addition as the second part.
I don't want it if it doesn't have the icing on it.
I know they got a bit big, but look how soft they are.
They definitely got a tad bit big.
I don't want it if it doesn't have the icing on it.
Do you see this cookie? Do you see the size of this little cookie? Yeah, look at that. Look at that sucker. Okay.
I'll go put this.
Is it? Oh, am I supposed to eat this?
No.
Oh. Well.
It's okay.
Okay. It's about to break.
Oh, is it?
Heavens to Betsy.
Oh, am I supposed to eat this?
All right. When it is sex-linked dominant, is it from father to daughter or mother to son? Which one is sex-linked recessive? Yes, I want the cookie too. All right, so the kind of common trick, Shaylin, is
Which one is sex-linked?
the recessive side, you'll see more mother to son. The dominant one, you will see father to daughter. Now, it doesn't mean that they can't inherit the other way. It just means the shading.
The dominant one, you will see
Okay.
father to
Who is Scott Brighton?
doesn't mean that they can't inherit the other way.
Who in heaven's name is that child?
Okay. Who is Scott Brighton?
Like,
Who
who?
in heaven's name is that child?
Okay. Anyway, Shaylin, back to your question. So,
Like, who?
Stingray double-sided Scooby snacks? What?
So,
Alright. So, Shaylin, in a situation where you have...
Scooby snacks?
Alright. Oh my heavens, y'all are... It's a little late now, apparently, because y'all are going off of topic. So, Shaylin, if we were to say that this is a sex-linked dominant situation, so the father is shaded, so he has a sex-linked trait. Well, what we're talking about is it's carried on his X. Well, he can only give an X to his daughter. So that means automatically his daughter has to be shaded in. Okay? Now, the reason this situation, this can't be sex-linked recessive. It can't be sex-linked recessive. Here's the reason. Because if it was sex-linked recessive, okay, well, it could still be, if this dad was recessive, so again, he has a recessive X that he's going to give to his daughter. But since mom isn't shaded, she has a capital X, a dominant sex linked. But she could be hetero, so she still could give her X to her daughter, right? But in this situation, and then the son, he may or may not. But it's a trick to say that in almost all sex linked dominant, you'll see a shaded dad pass his dominant X to his daughter. But then take the same situation.
You'll see a shaded dad pass his.
Okay. Take the same situation. Take a shaded mom.
But then.
So this is going to be sex-linked recessive. That means she is automatically expressing two lowercase e's. So she has to give her X to her son. And he only has one, so he has to express it. So he'll be shaded too. But she will pass down one bad X here. But if dad isn't shaded here, that means he has a good X. And that means that good X will cover up the bad one. So you'll never see a shaded daughter. You'll never see a shaded daughter. come from a shaded mom in a sex-linked recessive situation if the dad isn't also. This is why color blindness is so common in the males, because they got it from their mom. Okay? Now, it's a guarantee. If mom's colorblind, son's going to be colorblind. There's no ifs, ands, or buts about that. Like, that's a guarantee. If mom's heterozygous, she doesn't have to give him the colorblind X, but she could. He has a 50% chance, right? So, the sex-linked dominant, most commonly, you can see the shades for father and daughter. Sex-linked recessive, you see the shades more commonly for mom and son. It's not a guarantee. You're still going to have to work it out, though. And orange peanut, for me, I accept you. I want it now. I want it cake now. Pretty, huh? Hey, what in heaven's name are you saying? Okay, so when both parents are shaded. No, what is that?
It's the glaze.
Okay, baby. Alright, just a quick sec. Baby girl, it's confectioner sugar, which is powdered sugar, baby. She just used all my organic sugar on glaze that's supposed to be powdered sugar. How much of that did you just make? Oh my heavens to Betsy. No, it's supposed to be confectioner sugar is powdered sugar. So it's powdered sugar, so you need to go fix that glaze. I'll eat this, or at least I'll try a bite of it. That's our glaze. It's not normal.
Wait, so what am I supposed to do with all of that?
I have no idea at this moment, baby.
It's yummy.
Weird.
I think I haven't tried my own cookie. Oh.
I don't know, put it in a Tupperware bowl and put it in the fridge. We'll figure out something to do with it, but fix
Do you
your
like
glaze.
it? The taste?
Mm-hmm. Yeah, I like the taste since I had to fix your batter. She is a rookie, Patrick. She is a rookie.
Yeah, I like the taste since I had to fix your batter.
I'm not going to be there tomorrow, Chloe. All right, Shaylin, so when both parents are shaded and all of their kids are shaded, is that sex-linked? It could be. It very much could be.
All right, Shaylin, so when both parents are shaded and all of their
It could be sex-linked dominant. It could be sex-linked recessive. It can work out to be both of them.
It very much could be.
So on that one, it isn't enough information to just look at that. You would have to have more. You have to have grandparents, brothers, sisters to be able to determine. The pedigrees I give y'all tomorrow will be pretty cut dry. Okay.
You have to have grandparents, brothers, sisters to be able to determine.
Yeah.
The pedigrees I give y'all tomorrow will be pretty cut dry. Okay.
All right. Sorry, I have a cookie in my teeth now. Ah! All right. Can't really think of a whole lot more questions or anything. Is there anything that I'm like kind of skipping over? I don't think general Mendel is pretty straightforward, right? It's pretty easy. It's dominant recessive. Can you do a monohybrid cross? Do you know genotype from phenotype, right? The letters versus what do they mean? But then of course we added on top of that sex-linked. Then we added pedigrees. Then we added chi-square, law of multiplication, law of addition, linkage maps.
And we added pedigrees.
Is it worth staying up and studying all night for this test? No, it is never worth staying up all night and studying for any test, Shaylin, because you're actually supposed to get two REM cycle sleeps for information to stick. So, yes, sacrifice for Mendel. No, that'd be more like evolution and the natural selection of the species, whether or not you would survive and make a good grade on the test from an all-nighter. No, I don't anticipate this being horrible. I know some of y'all maybe still have some difficulties with the chi-square and stuff. Look at that worksheet. Go through the video again. How many hours is 2 REM cycles?
chi-square.
It's usually 2 nights.
Look at that worksheet.
Yeah,
Go through the
usually
video
2
again,
nights,
how many
sweetie.
cards
I'm sorry to
there's
say.
2 web cycles.
Look at the answer key. I don't know, Patrick.
Sweetie, I'm sorry to say. Look at the answer.
Please give us some low-hanging fruit.
I don't know, Patrick.
Low-hanging fruit. That's funny. What was I gonna say?
Low-hanging fruit.
Oh, look at the test review answers in your folder. Look at those. Look at the Bozeman. Do the quizzes. Don't.
Look at the test review.
Okay, Mr. Williams.
In your
T, how did you and why did you get on here? Oh heavens, we will bake you cookies. Oh heavens. Okay, I think y'all are derailing. Please, are you saying please to the cookies or please to the low-hanging fruit?
Oh heavens. Okay, I think y'all are derailing.
Like I said, I still have to finish kind of writing the questions. Glossy, that's Gaussy and colored. What in heavens is a Gaussy?
Like I said, I still have to finish
Glossy, that's Gaussy, and call it a day.
What in heavens is Gaussy?
Low-hanging fruit. I will try and give y'all some low-hanging fruit. Sheesh. Y'all are so crazy. Go back through at the beginning of the video where I went through the chi-square for that problem on y'all's worksheet. Try and look at that. I'll leave some notes that y'all can have some time to study for a few minutes. And then, is there anything else I can answer for y'all? Sorry we got started late. Oh, wow.
Is there anything else I can answer for y'all? Sorry we got started late.
T. All right. All right. Well, I'm really glad I got to, go live in while I'm getting ready for bed. Yeah.
Well, I'm really
With my
glad
daughter,
that,
not in bed like she should be.
And,
She's in there saying I heard that.
with my daughter.
All right.
Not in bed. Like
Okay, well, we'll have to do this again. Certainly.
she's in there saying I
Could you
heard that.
talk through number 8 on the review real quick? What is number 8?
Okay, well, we'll have to do this again.
Just do the law of multiplication. Yeah, what's number 8, Shaylin?
On the review real quick. What is number 8?
I don't have, I can try and pull it up on my phone real quick.
To the law of multiplication. Yeah, what's number 8, Shaylin?
Thank you so much, Miss Good. It was actually super helpful.
Okay,
Good deal.
I can try and pull it up on my phone real quick. Thank you so much, Miss Good. It was actually super helpful. Good deal.
Like I said, we'll do this again now that I have everything downloaded. It won't take forever and a day.
Like I said, we'll do
It's
this
really
again
long.
now.
I'm trying to pull it up too
It won't take forever
on
and
my
a day.
phone. So hold on.
It's really long. I'm trying to pull it up too on my phone. So hold on. It's really long. I'm trying to pull it up.
Okay. Oh, don't forget blood types A, B, and O. That A, B are both dominant, therefore they are codominant together, while O is truly a recessive.
Oh, don't forget blood types A, B, and O.
I'm pulling up things, so I'm realizing some things that could be,
while O is truly a recessive. Oh, don't forget blood types A, B, and O. I'm pulling up things, so I'm realizing some things that could be, while O is truly a recessive.
okay.
I'm pulling up.
Describe state Mendel's law of independent assortment, law of segregation, to describe how this law can be explained by the behavior of chromosomes dermeiosis. All right, so So law of independent assortment and law of segregation, the reason they can be explained through meiosis is because both of them, you can see the beginnings of the law like explained in metaphase for both, but then they complete in anaphase for both. Simply all that is the law of segregation is when meiosis is completing, meiosis 2, and you're making your 4 gametes, you have 4 copies now total of a gene, right? You have your mom's chromosome and your dad's chromosome that both replicated. Okay, so you have mom, you have dad. Mom chromosome replicated, dad's chromosome replicated. All the way at the end of meiosis, you'll make your 4 gametes, and those 4 chromosomes will separate, okay? Law of segregation describes this part. Why? Because segregation is all about the alleles. That if mom just so happened to be heterozygous, right? I didn't mean heterozygous. So if she's, if this chromosome was A, but then dad's chromosome that you inherited was recessive, right? So the egg or sperm, whatever you are, whatever you're creating, then over here you would have gotten dominant A's, and over here you would have gotten recessive A's. So think about it. For you, your brother, your sister, whatever, y'all are created out of different eggs and different sperm. So the law of segregation describes how one trait's alleles, so these alleles, separate from each other at the end of meiosis. Okay, trying to get this in. Law of independent assortment is earlier up here, how traits on different chromosomes. So like mom and dad here, but then chromosomes, the chromosome number 2 have E and E on them. Independent assortment is why, Gracie, I think he needs to go outside. Oh, okay, just go. Independent assortment is how A trait and E trait will separate from each other. They don't have to go in the same gametes as each other. So you can kind of think of it as the law of segregation is concerned with the alleles of one trait. The law of independent assortment is more concerned with multiple trait. Okay? How the chromosomes and the genes carried on mom and dad's chromosomes don't have to influence each other. Here's another way to look at it. Law of segregation can be explained when doing a monohybrid cross. Law of independent assortment can be explained when doing a dihybrid cross. How the R and the Y of the round and yellow peas did not have to stay together, and you create all those variety of phenotypes and genotypes. Okay? Can we have like half of the test be about blood types, because I was distracted one day and researched it for a few hours. Chloe. Okay, thank you, baby.
That better?
Now she made the correct glaze. Mm-hmm.
Pass it, take, pass it.
Okay, thank you, baby.
That better?
Now she made the correct glaze.
Yes, it's better. The cookies are a little flat. I'm curious how you put them on. Did you roll them up in a ball when you put them on there?
Nope.
All right. This is what happens when you don't roll your cookies up into a ball. They
The
get.
dough wasn't doughy.
The dough wasn't doughy. She probably didn't let it sit in the fridge long enough.
All right. This is
still good.
When you don't roll your cookies up into a ball, they get. The dough wasn't doughy. She probably didn't let it sit in the fridge.
You're welcome, Shaylin. All right. Well, I don't know if this video saves or not.
You're welcome, Shaylin.
It may delete. I have no idea. But anyways. Alright.
I don't know.
I'm going to be withdrawing my kids from school and everything. I have to come up in the morning and print off y'all's tests. But other than that, y'all can hit me up if y'all need me, okay? Alright. Good night, guys. Bye, John.
And everything. I have to come up in the morning.
Savage they are.
For
Yes,
help.
seriously, right?
Y'all can
Yeah.
hit me up if y'all need me, okay? All right, good night, guys.
All right, I'm gonna see if I can stop this.
I'm not sure why conjugation is coming up. Did I have that somewhere on a review? That's just odd. Because conjugation was meiosis. Conjugation is